Hello all, my name is Rohit Gupta. In today's class I will be teaching you electricity of class 10 CBSE. The first thing which we will be learning in electricity is about charge. Charge is denoted with a symbol Q and unit. Charge is measured in coulomb. Okay, charge is measured in coulomb. In charge we are having two types. One is positive charge, another one is negative charge. A body is said to be positively charged if there is excess amount of positive charge. A body is said to be negatively charged if there is excess amount of negative charge. A positively charged body and negatively charged body are kept in contact, then there will be a transfer of charge. Okay, yeah, only electrons are transferred, protons we can't transfer. Only electrons can be transferred. So in the above situation, one electron got transferred. If one electron is transferred, 1.6 into 10 to the power of minus 19 coulomb of charge is transferred. So this is called fundamental charge of electron. If one electron is transferred, 1.6 into 10 power minus 19 coulomb is transferred. Okay, if 10 electrons are transferred, 10 into 1.6 into 10 to the power of minus 19 coulomb is transferred. If 20 electrons are transferred, 20 into 1.6 into 10 power minus 19 coulomb is transferred. So for n electrons, if we want to find how much charge is transferred, the formula is Ne. So this is your first formula. Okay, where n is what? Number of electrons. Q is what? Amount of charge transfer. E is what? Fundamental charge of electron. So I'll give you a few questions so that we can understand better about this formula. Okay, if 4 electrons are transferred, how much charge is produced? So we know the formula Q is equal to N into E. We know 4 electrons means number of electrons are 4. We know E value is what? 1.6 into 10 to the power of minus 19. So 4 into 1.6 is what? 6.4 into 10 to the power of minus 19. We know what charge is measured in coulomb. So answer is what? 6.4 into 10 to the power of minus 19. Similarly, if 10 electrons are transferred, how much charge is transferred? So we know what Q is equal to N into E. We know what N is equal to 10. E value is what? 1.6 into 10 to the power of minus 19. So you might be doing like this: 10 into 1.6 is 16, and you will be writing answer like this. But you should not stop here. Whenever our answer is in the form of A into 10 to the power of D, A should be between 1 and 10. This is called a standard notation which we need to follow. So this 16 we can write as 1.6 into 10, 10 into 10 power minus 19, which is nothing but 1.6 into 10 to the power of minus 18 coulomb. So directly you can do here also 1.6 into 10 to the power of minus 18 coulomb. Okay, no need to do all this thing. For your understanding, I told this. So whenever your answer is in the form of A, A into 10 to the power of b, A should be between 1 and 10. Remember this thing. This is called standard notation. Or else what will happen means 16 into 10 power minus 19. Some other person will write 160 into 10 power minus 20. Some other person will write 1600 into 10 power minus 21. Everything is current. Now next question. Is it possible to transfer 4 into 10 to the power of minus 19 coulomb? So is it possible to transfer 4 into 10 to the power of minus 19 coulomb? If yes, then why yes? If no, why no? That we need to do. Okay, we know the formula. Q is equal to n into E. We know Q value is what? 4 into 10 to the power of minus 19. E value is what? 1.6 into 10 to the power of minus 19. This 10 power minus 19, 10 power minus 19 gets cancelled. So n is equal to what? 4 divided by 1.6. This we can write as what? 40 by 16. 1.6, 16 by 10. So 2 8s are 2 20s are 2 4s are 2 5s are what is 5 by 4? 1 point something. 4 ones are 4, 4 2s are 1.25. So is it possible to transfer 1.25 electrons? Yes. No, right? Oh, here I did a mistake. Sorry. Two tens are 10 by 4. 10 by 4 is nothing but 2.5. Now, is it possible to transfer 2.5 electrons? No, it is not possible. We can transfer 2 electrons or 3 electrons. We can't transfer 2.5 electrons. So answer is no, it is not possible. Got it? Please copy. So here you need to understand number of electrons. Number of electrons will be in integer. Okay, number of electrons will be in integer. We won't be getting any fractional value. So a body has a charge of 4.8 into 10 to the power of minus 19 coulomb. Calculate the number of electrons it has gained or lost. This was asked in 2014, 17 and 23 sample paper. Okay, given what charge value is given 4.8 into 10 power minus 19 coulomb. Calculate the number of electrons n we need to find. We know what E 1.6 into 10 to the power of minus 19 coulomb. This you need to remember. Okay, so we know what Q is equal to Ne. To find number of electrons we can write n is equal to Q by E. What is Q value? 4.8 into 10 to the power of minus 19 coulomb upon E value is what? 1.6 into 10 to the power of minus 19 coulomb. This coulomb gets cancelled. 10 power minus 19, 10 power minus 19 gets cancelled. 4.8 divided by 6 is nothing but 3. So 3 electrons. We got number of electrons. Now it has gained or lost. Now remember, this charge is positive. So if a charge is positive, it means it have lost electrons. If charge is negative, it has gained electrons. If something gains electrons, means it is getting negative charge. Now if it has a positive charge, it means it has lost electrons. So answer is lost. Okay, it has lost 3 electrons. Because of that, this there is this much charge. Okay, now let us go to next topic. Current is denoted by symbol called I. What is current means? Rate of flow of charge. Rate of flow of charge gives current. What is the meaning of rate of flow of charge? Charge is nothing but Q. What is the meaning of rate means? By T. Okay, here charge should be in coulomb, time should be in seconds. Now what is 1 coulomb per second? 1 coulomb per second is nothing but 1 ampere. So current is measured in coulomb per second or ampere. This coulomb per second we can also write as ampere. Now question, if 120 coulomb of charge is passed in 2 minutes. Find current. So the formula is very simple. I is equal to Q by T. Now you should know charge and time. Charge, what is charge? 120. What is time? 2 minutes. Now here the mistake most people will do is they will be writing 120 by 2, they will be getting answer as 60, but you should not write 2 minutes because time should be taken in seconds. Okay, so 2 minutes is what? 120 seconds. So answer is what? 1 ampere. 1 ampere, simple one. Okay, 1 coulomb of charge flows through a conductor in 1 second. Find the current. So given charge is 1 coulomb and time is given as 1 second, they are asking us to find the current. We know the formula. I is equal to Q by T. Q value is what? 1. Time is what? 1. This is in coulomb, this is in second, so answer is 1 ampere. Okay, coulomb per second is ampere, right? So current is 1 ampere. So if 1 coulomb of charge flows in 1 second, that is nothing but 1 ampere. So they can give you a question like this also. Define 1 ampere. Define 1 ampere. Okay, if 1 coulomb of charge is passed in 1 second, gives 1 ampere. So this is the definition. Okay, if they ask you what define 1 ampere, if 1 coulomb of charge is passed in 1 second gives 1 ampere. Okay, like this you need to tell. A current of 0.5 ampere drawn by a filament of an electric bulb for 10 minutes. Find the electric charge through the circuit. Listen, given current is equal to 0.5 amp by a filament of an electric bulb for time 10 minutes. We know what time we need to take in seconds. So 10 minutes is nothing but 10 into 60. 600 seconds. Find the electric charge. We need to find what? Electric charge. Now we know the formula. I is equal to Q by T. You need to find Q. So Q is equal to what? I into T. What is I value? 0.5. And time is what? 600. 0.5 is nothing but 5 by 10. 1 by 2. 1 by 2 into 600 is what? 300. A current of 10 amperes flows through a conductor for 2 minutes. So given current is equal to 10 ampere and time is given as 2 minutes. 2 minutes we can write as 2 into 60, 120 seconds. Find the charge. So you need to find charge. Next you need to find what? Number of electrons. Now listen, we know what I is equal to Q by T. So Q is equal to what? I into T. Current is given as 10 ampere. Time is given as 120 seconds. Charge is equal to what? 1200 coulomb. Now number of electrons. To find number of electrons we can write what? Q is equal to N into A. So what is charge? 1200. N we need to find. E value is what? 1.6 into 10 to the power of minus 19. This formula we need to use to find N. So N is equal to what? 1200 divided by 1.6 into 10 power minus 19. Now this 10 power minus 19 we can send as 10 power plus 19 to the numerator. This 1.6 I can write as 16 by 10. That 10 I can send to numerator. Now this, if I cancel, I will get the answer. So this both are, I can cancel in 4 table. 4 4s are 16. 4 into 300. 2 2s are 2 150s are. What is 150 by 2? 75. 75 into 10 to the power of 20. This many number of electrons. So this is the answer. Calculate the number of electron constituting 1 coulomb of charge. So listen, we need to find what? Number of electrons. Given charge is what? 1 coulomb. We need to find N. We know Q. So the formula is what? We know something called Q is equal to N. So N is equal to what? Q by E. What is Q value? 1 coulomb. What is E value? 1.6 into 10 to the power of minus 19. So this 10 power minus 19, if we send above, it will become 10 to the power of plus 19. Here we're left with what? 1 divided by 1.6. This 1.6 we can write as 16 upon 10. That 10 we can send above. This will be what? 2 5s are 2 8s. If you divide this 0.0 8 6 are 48. So 2 0 8 2 are 16 4 0. So 0.625 0.625 into 10 to the power of 19. So I have already told you, whenever our answer is in the form of a into 10 to the power of b, a should be between 1 and 10, but this is 0.625, which is less than 1. So this I will be writing as 6.25 into 10 to the power of minus 1. I can write 0.625 as 6.25 into 10 power minus 1. Here we are already having 10 power 19. So n value will become what? 6.25 into 10 to the power of 18. So this you will be getting as MCQ also. Remember, you can also remember this answer. Calculate the number of electrons constituting 1 coulomb of charge. So answer is what? If we pass 6.25 into 10 to the power of 18 electrons, then we will be getting 1 coulomb of charge. Till now what we have learned? We have learned two formulas. Q is equal to Ne and I is equal to Q by T. Sometimes in place of Q we can write Ne. Why? Because they will be asking you to find number of electrons. They will give you current and time. So these are the two formulas which we have learned. Q is equal to Ne, I is equal to Q by T. In place of Q we can write Ne. We can equate like this: I is equal to Ne by T. Okay. Sometimes they will tell you to find, they will ask you to find number of electrons, then this formula will help you. Okay. Remember, this N is number of electrons, which is basically an integer. You should not get any decimal value. Okay. Charge is measured in coulomb, current is measured in ampere. Now there are some units which you need to learn. 1 millicoulomb is nothing but 10 power minus 3 coulomb. Sometimes I will give you in terms of millicoulomb. You need to convert into coulombs. They will give you 1 microcoulomb. 1 microcoulomb is nothing but 10 power minus 6 coulomb. So these are your key takeaways. Okay, till now what we have learned is basically this thing. Okay, Q is equal to Ne, I is equal to Q by T. Where E is what? Fundamental charge of electron, which will be having a fixed value 1.6 into 10 to the power of minus 19 coulomb. This you need to remember. Just you need to apply somewhat max. Okay, next topic. Potential difference. What is potential difference? Okay, so listen, let us take a conductor. What is conductor? You know what is conductor and insulator, right? Something which allows current. Something which allows current is called a conductor. Something which don't allows current is called an insulator. Okay, this is a conductor. Okay, in conductor there will be free electrons. These free electrons will move in random direction. These free electrons will move in random direction. So what we need to do is we need to find net charge. To find net charge, what I did is I took a cross section. Okay, like this I'm taking a cross section. In this cross section, how many are moving from left to right, how many are moving from right to left, I need to check, and I need to subtract. Interestingly, I will be getting a value called 0. So this it means how many are going from left to right, that many are going from right to left. Okay, if net charge is 0, what will happen? We know what? I is equal to Q by T. If net charge is 0, current will be what? 0 ampere. So conductor allows current to flow, but if you touch that conductor, you won't be feeling any shock. When we will be feeling shock? When conductor is connected to a wire, that wire is connected to a battery. Okay, now what will happen means, when we connect a battery will be having some potential difference. Because of this potential difference, this electrons will flow towards positive. Why electrons will flow towards positive means, electrons are negatively charged, so they will attract to positively charged body. Okay, so this electrons will move, electron flow towards positive charge, towards positive charge. Now interesting thing is current. Direction of current is opposite to flow of electrons. Direction of current is opposite to flow of electrons. So if electrons flow towards positive, current will flow, it will flow towards negative. Towards negative potential. Okay, so when a battery is connected to a conductor, there will be some net charge. Okay, there will be some net charge, because only how to find net charge, we know how much charge is producing from left to right, how much charge is produced due to right to left, that we need to do. Interestingly, here we won't be getting any zero because all are moving in one direction, so the net charge is not equal to zero. Because of that, current is also not equal to zero, there will be some current. Because of that conductor, when you keep a wire, if you touch that conductor, you will be getting a shock. So that's why for that conductor we will generally do insulate it. Okay, so direction of current is what? Positive to negative. Direction of electron is what? Negative to positive. This which you need to remember, this you can get in your exam. Okay, direction of electron is what? How to remember? Electrons are negatively charged, so they will attract towards positive charge. Current direction is what? Opposite to flow of electrons. Okay, opposite to flow of electrons. It can also be written as, it will pass along positive charge. Okay, along positive charge. Positive charge is nothing but proton direction. Okay, if electrons are flowing in this direction, protons will flow in this direction. So current direction will be what? Along protons. Clear? Now listen, what is the purpose of a battery? When we connect a battery, electrons will flow in a particular direction, right? So battery will be having some potential, it will do some work to move charge from negative terminal to positive terminal. So this is your new formula. V is equal to what? W by Q. Listen carefully. Battery will do some work to move electrons from negative to positive charge, negative terminal to positive terminal. So work done. Work is measured in joules, charge is measured in coulomb. So V is equal to W by Q. Let us solve one question. Calculate the amount of work done by a cell of 20 coulomb of charge is moved through a potential difference of 3 volts. Now calculate the amount of work done by a cell of 20 coulomb of charge is moved through a potential difference of 3 volts. We know what? V is equal to W by Q. Calculate the amount of work done, so we need to find what? W. 20 coulomb, so charge is given as what? 20 coulomb. Potential difference is what? Nothing but 3 volts. So 3 is equal to W by 20. So W is equal to what? 20 into 3, which is nothing but 60 joules. So the work done is equal to what? 60 joules. So like this you need to apply this formula. The next question, how much work is done in moving a charge of 2 coulomb across 2 points having potential difference 12 volts? So listen, given charge is equal to 2 coulomb, potential difference is equal to 12 volts. Okay, what they are asking, they are asking us to find work done. This was asked in CBSE 2023 paper. The formula is simple, V is equal to W by Q. So we need to find W, so V into Q. What is voltage? 12. What is charge? 2. 12 into 2 is what? 24. Work is measured in joules. The answer is 24 joules. A battery does 300 joules of work. So given is what? Work done is equal to 300 joules. Is transferring of it 20 coulomb of charge. So charge is given as 20 coulomb. Calculate the potential difference. Potential difference means what? V value across the terminals of the battery. V you need to find. This is a 2020 paper, so we know the formula. V is equal to W by Q. Work done is equal to 300 and charge is equal to what? 20. 0 0 gets cancelled. V is equal to what? 30 divided by 2, which is nothing but 15. Voltage is measured in volts. So difference between potential difference and voltage, understand? So most of the people confuse in this point, in this topic. They understand that potential difference and voltage both are same. So when we will be calling as potential difference and when we will be calling as voltage. For example, if a battery has positive terminal voltage as 20 volts, negative terminal voltage as 18 volts, what is the potential difference? 20 minus 18, 2 volts. Okay, this is called potential difference. Okay, positive terminal will have some voltage, negative terminal will have some voltage. That too, if you subtract, you will be getting some voltage, right? That is potential difference. Okay, so here we will be writing what? V is equal to W by Q, right? This is the formula where V is what? Potential difference. Okay, in last question I had given potential difference value directly. Now I can give you value in terms of positive terminal and negative terminal. When positive terminal voltage and negative terminal voltage is given, what you need to do? You just need to subtract it. You need to find potential difference. For example, if a 5 coulomb of charge is passing from 10 volts to 20 volts, find the amount of work done. Find the amount of work done. Now listen, there is some 5 coulomb of charge which is passing from what? We know what? Electrons flow from negative terminal to positive terminal, right? If I take a conductor, I'll draw nicely. If I take a conductor, electrons will flow towards positive charge. So we are having something called 10 volts. From 10 volts it is passing towards 20 volts. So flow of electrons is from 10 volts to 20 volts. So what is potential difference? 20 minus 10, so 10 volts. So this V is nothing but what? Potential difference. So in this question they had given positive terminal value and negative terminal value. So to find potential difference, understand, you need to subtract higher value minus lower value. Simple. We know the formula. V is equal to what? W by Q. Potential difference is what? 10 volts. And work done, we need to find. Charge is given as 5. So 10 into 5. Work done is equal to what? 50 joules. So like this you need to do. Okay. So potential difference is difference of positive and negative terminal voltage, or else higher potential minus lower potential. This positive terminal, negative terminal will have some voltage. Positive terminal has, here I can say positive terminal has 10 volts. Sorry, positive terminal has 20 volts, negative terminal has 10 volts. Potential difference is 10 volts. Okay, potential difference is 10 volts. I can't tell potential difference of positive terminal is 20 volts. Understood? So positive terminal value we will tell as voltage, negative terminal value we will be telling as voltage. This difference we will be calling as potential difference or potential difference. That's it. Is an ammeter. Ammeter is a device used to measure electric current. Okay, it is always connected in series. It should have low resistance so that it may not change the value of current. So understand this term. So why an ammeter is used? To measure electric current. Here it is always connected in series. Why? What is that series connection? We will look into it. For now, remember this thing. Ammeter is always connected in series. It should have low resistance. What is the meaning of low resistance? Resistance means what? Something to resist. Okay, something to resist. If ammeter has low resistance, it can low resistance means what? It should not resist only, right? If it has high resistance, it will resist more. Okay, it should allow current to it, then only it can measure. So it should have low resistance. Okay, it should have low resistance so that it can allow current. It can show you correct value of current. Okay, this point is important. Why ammeter will have low resistance? If it has low resistance, it can allow more current. It can allow current, and it will show you an exact value of current. Voltmeter. It is a device used to measure potential difference. It is always connected in parallel. It is always connected in parallel. Voltmeter is always connected in parallel. It has high resistance. Voltmeter has high resistance. Something which has high resistance, it won't allow what? Current. So it will take negligible current. It will show you exact voltage value. If it takes current value, it will voltage value won't be that much proper. So that's why voltmeter has high resistance and ammeter has low resistance. Let us take a circuit and understand. Okay, this is a resistor, this is a battery, and this is a key. Okay, this is a closed key. When key is closed, current will pass from positive terminal to negative terminal. Now I need to connect ammeter I need to connect series. In series I need to connect. Voltmeter I need to connect parallel. Okay, this is how we will connect ammeter or voltmeter. Got it? Like this we need to connect. Okay, if current enters, you need to keep plus sign. If current leaves, you need to keep negative sign. So current enters from here, that's why plus sign. Got it? So this is series and parallel. Series means what? Along. Parallel means what? Somewhat above. Components in circuit diagram. Okay, in circuit we will be having so many things. For example, electric cell. Electric cell is denoted by this symbol. Series of cells is called a battery. Next, this is called open key. Okay, and this is called a tap key. Generally we will be using a tap key only, right? In our home we will be using a switch, that is a tap key. That tap key is opened. Now closed key. Closed key, how we will represent is, we will just keep a dot there. The tap key, if we click on the tap, it will get fall on down, right? So tap key is closed, so current will pass. This is a wire joint, like this, a joint wire is joined. Now wire crossing without touching. So if we keep wire above another wire, there is a possibility like this, or else there is a possibility like this. If wires are not touching, we need to keep like this. Okay, the wire is not touching. Now this is called fixed resistor, a resistor which has a fixed resistance. Variable resistor. Variable resistor means what? Resistance is not fixed, we can change the resistance value. Remember the symbols. Now ammeter, this is ammeter symbol, and this is voltmeter symbol. How do we get questions from this topic? Means identify the following symbols of commonly used components. Okay, this is what? A variable resistor. This is what? A closed key, right? Now draw a schematic diagram of a circuit consisting of a battery of 3 cells. There are battery of 3 cells. Okay, we are having 3 cells. Each cell has 2 volts, so 3 cells will be having 6 volts. A 5 ohm resistor, there is a 5 ohm resistor. Okay, and 10 ohm resistor and an ammeter, plug key, all are connected in series. 5 ohm, 10 ohm. There is an ammeter, keep ammeter here in series. All current value is same, you can keep anywhere. Plug key, plug key you need to keep. Okay, there is a plug key, all connected in series. Okay, this key we can close so that current will pass from positive terminal to negative terminal. Okay, here you can keep plus minus, plus minus, plus minus. Okay, this is how circuit diagram we need to draw. Okay, I think I have filled everything. 3 cells of 2 volts, so 6 volts, 5 ohm resistor, 10 ohm resistor. Okay, ammeter, plug key, all connected in series. If at all, if they give you voltmeter also, you can connect voltmeter like this. Individually, here we need to take 2 voltmeter or else 1 voltmeter first connected to 5 ohm, next another voltmeter connected to 10 ohms. Voltmeters are always connected in parallel. Okay, in this question they have not asked, just I have connected. Okay, next topic, Ohm's law. The potential difference across the ends of conductor is directly proportional to current flowing through it. So at constant temperature, potential difference is directly proportional to current. So if proportionality is removed, there will be a constant. That constant is R. Or else na, V by I is nothing but constant. V by I value is nothing but constant. That constant is nothing but what? R. Where R is called resistance, which is measured in ohms. This is the symbol of ohms. Okay. If you draw a graph between voltage and current, as you know, voltage is directly proportional to current. As voltage is directly proportional to current, you will be getting a straight line graph. Now at any point, if you want to find resistance, so what you need to do is, at this point I want to find resistance, so I need to know this voltage value, I should know this current value. If I know that current value and voltage value, if I divide that V by Y, then I will be getting R value. Okay, for example, here if it is 10 volts, here it is 2 amps, so what we can tell, resistance is equal to 10 by 2, which is nothing but 5 ohms. If a graph is given, if they ask you to find R value, so what you need to do, you need to take a point. At that point you need to locate what is the voltage and what is the current. If you know voltage value and current value, just divide it, you will be getting what? Resistance value. Okay, now in this graph, at any point, if you find voltage and current, for example, if this is 20 volts, this will be 4 amps. If you do this 20 by 4, you will be getting again 5 ohm. So at any point, resistance will be constant. So here, so that's why in place of constant we are writing what? Resistance. Okay, at any point the resistance will be same. Clear? I'm taking three different instruments, okay, which are having three different resistance. Okay, now there is another method. One method is what? V by I value. Another method is slope. If you find slope, that will give you what? Resistance value. So how to find slope? To find slope, the formula is tan theta. To find slope, what is the value? Tan theta. Now what you should do is, for example, if here this line is making 30 degrees, this line is making some 45 degrees, and this line is making some 60 degrees. Now in this I want to find R, in this I want to find R, in this I need to find R value. They had not given any voltage value and current value, they had given this theta value. Now tan theta will give you what? Resistance value. Now what we can write? R is equal to tan 30. What is tan 30? Sin 30 by cos 30. 1 by 2 by root 3 by 2, which is 1 by root 3. Here tan 45. Tan 45 is nothing but 1. Here tan 60. What is tan 60? Sin 60 upon cos 60. Sin 60 is root 3 by 2, cos 60 is 1 by 2. Root 3 by 2 by 1 by 2, root 3. Like this you can find. Clear? Now, based on this concept, we are having a problem. Study the IV graph for 3 resistors of the resistance R1, R2, R3. Select the order of the statement. Okay. Now what we can see is, here we are having one angle, this R2 is making some other angle, R3 is making some other angle. We know, right, for tan theta, if angle is getting increased, the value will also get increased. Tan 0 is what? 0. Tan 30 is what? 1 by root 3. Tan 45 is what? 1. Tan 90 is what? Infinity. As we increase the angle, this value is also increased. So if you see, this theta 1, theta 2, theta 3, theta 1 is greater than theta 2, theta 2 is greater than theta 3. So tan theta 1 value will be greater than tan theta 2, then tan theta 3. So R1 value will be greater than R2, R2 value will be greater than R3. Like this you need to solve. A potential difference of 12 volts is applied across a resistor if the current through it is 3 ampere. Calculate the resistance. They are asking us to find resistance. They are given V and I. So V, I and R, related formula is what? V is equal to IR. So R is equal to what? V by I. What is voltage? 12. What is current? 3. So answer is what? 4 ohms. That's it. A simple electric circuit has 24 volt battery. So given voltage is equal to what? 24 volts and resistor of 60 ohms. R is equal to what? 60 ohms. What will be the current value? So they had given V, they had given R, they are asking us to find I. We know what V is equal to IR. So I is equal to what? V by R. Voltage is given as 24 volts. This value is given as 60. 12 2s are 12 5s are. So 0.4 ampere. An electric iron draws a current of, there is an electric iron, means iron press, draws a 3.4 ampere current when it is connected to 220 volts. Okay. What current will this electric iron draws when connected to 110 volts? So same thing, how much current it will draw when it is connected to how many volts? 110 volts. Now listen, let us assume this is I1 V1 and this is what? I2 V2. According to Ohm's law, what we know? V by I value is constant, which means if we do V1 by I1, we will be getting some value. Similarly, if we do V2 by I2, we will be getting what? Same value. V1 by I1 value will be equal to what? V2 by I2. What is V1 value? 220. What is I1 value? 3.4. What is V2 value? 110. What is I2 value? We need to find. So from this what we can write? I2 is equal to, I2 we can send here. This 220 by 3.4, if we send here, it will become what? 3.4 by 220. So 0 0 gets cancelled. 11 ones are 11 twos are. Now 3.4 divided by 2. 2 ones are 2. 1.7. So current is 1.7 ampere. An electric room heater draws a current of 2.4 ampere from voltage of 120 volt supply line. What current will this room heater draw when connected to 240 volts supply line? We know what? V1 by I1 is equal to V2 by I2. V1 is what? 120. I1 is what? 2.4. V2 is what? 240. I2 we need to find. So I2 value will become what? 240 into 2.4 divided by 120. 0 0 gets cancelled. 12 ones are 12 twos are. 2.4 into 2 is what? 4.8. Name the electrical property of material whose symbol is omega. So omega is nothing but ohm. What is the electrical property? Resistance. Resistance is measured in omega. The graph between Vi for the conductor is a straight line passing from origin. So there is a graph between V and I, so which is passing through origin, the two a straight line. Which law illustrated by such a graph? What is that law? Ohm's law. What should remains constant in the statement? What is constant in this? Resistance. Now a current of 200 milliamperes. So current value is given as 200 milliampere. So this we can convert into ampere. 1 milliampere is equal to how many ampere? 10 to the power of minus 3. Resistance is equal to what? 4 kilo ohms. So what we can write? 4 into 10 cube ohms. What is potential difference? V they are asking. To find V, what is the formula? I into R. What is I? 200 into 10 power minus 3. What is R? 4 into 10 power 3. So 200 into 4 is what? 800. 10 power minus 3, 10 power plus 3 will get cancelled. So voltage will be what? 800 volts. A potential difference of 10 volt is need to make a current of 0.02 ampere flows through a wire. What potential difference is needed to make a current of 250 milliampere? So listen, this is in milliampere, you need to convert into ampere. So 250 into 10 to the power of minus 3 ampere. So here you need to remember 2 units. 1 milliampere is 10 power minus 3 ampere. They can also give you in microampere. Microampere is 10 power minus 6 ampere. These conversions you need to remember. So let us assume this is V1, I1, V2 we need to find, I2 is given. We know what V1 by I1 is equal to V2 by I2. V1 is what? 10. What is I1? 0.02. What is V2? We need to find. What is I2? 250 into 10 power minus 3. So to find V2, what we can write? 10. 0.02 we can write as 2 into 10 to the power of, very good, 250 into 10 power minus 3 we can send here. 2 ones are 2 5s are, so 5. Here we are having what? 250, 10 power minus 3, 10 power minus 2 if we send above, it will become what? 10 power plus 2. So minus 3 plus 2 value will become what? 10 power minus 1. 5 into 250 is what? 25 5s is what? 125. So 1250. 1250 into 10 to the power of minus 1. So 1250 into 10 power minus 1 is what? 125 volts. So voltage is 125 volts. Factors affecting the resistance of a conductor. Now till now what we have learned is resistance is constant, right? V by I is value is constant. That constant value is resistance. Now factors on which resistance of a conductor depends. Now when the resistance will change? Resistance depends on the length of conductor. If length of conductor is increased, resistance will increase. Length of conductor is decreased, resistance will decrease. So when length is getting increased, area will be decreased, right? This new area value will be decreased. So when length is getting increased, area will get decreased. When area is getting decreased, resistance will increase. So resistance is directly proportional to length and resistance is inversely proportional to area. From this two, what we can write is R is proportional to L by A. So if proportionality is removed, there will be a constant. That constant is rho. Rho is called resistivity. It is also called as specific resistance. Rho. This is called rho. Rho is called resistivity or specific resistance. Now this resistivity, it depends on material. Okay, it depends on material. If material is changed, then only this resistivity will change. It doesn't depends on length. It doesn't depends on size. Okay, for example, if you take a gold of this much size, resistivity will be same compared to a gold of this much size. Okay, For a material it will be having a resistivity. It doesn't depends on the size. Small material small resistivity, big material big resistivity. There is no relation like this. Okay, resistivity depends on what? Material. If material is changed, resistivity will change. Compare gold and silver resistivity, it will be different. But gold you are comparing of different size, that resistivity will be same. That you need to remember. Now resistivity is measured in which unit? What we can write? Rho is equal to Ra by L. Resistance is measured in ohm, area is measured in meter square, length is measured in meter. So the unit is what? Ohm meter. Resistivity is measured in ohm meter. We know what resistivity will be constant for different material. For example, silver will have resistivity 1.6 into 10 power minus 8. Copper will have a resistivity of 1.69 into 10 power minus 8. Aluminium has 2.63 into 10 power minus 8. Tungsten will have 5.2 into 10 power minus 8. So like this we are having some 9 metals. Okay, we are having some range, right? What is the range? Metals are having 1.6 into 10 power minus 8 to 184 into 10 power minus 8 ohm meter. So something which is having resistivity between 1.6 into 10 power minus 8 to 184 into 10 power minus 8 ohm meter, they are called what? Metals. Okay, this range you need to remember. This values however we can't remember, right? This range we can remember. So 1.6 into 10 power minus 8 to 184 into 10 power minus 8. If resistivity is between these two values, then they are called metals. If you see alloys, we do have something called 44 into 10 power minus 8, 49 into 10 power minus 8, 110 into 10 power minus 8. So these are also in between this range only. But listen, silver, copper, aluminum, tungsten, nickel, iron, chromium, mercury, manganese, these are all metals which we generally know. Manganese is a combination of copper, manganese and nickel. Okay, manganese is what? Alloy. Constant 10 is what? It is a combination of copper and nickel. This is an alloy. Nichrome is what? It is a combination of nickel, chromium, manganese and ferrous. So these three names you remember. This will come under alloys: manganese, constant 10, nichrome. Semiconductors: germanium, silicon, germanium, glass are semiconductors. Sorry, germanium, silicon are semiconductors. Insulators. Now listen, here we are having something called 10 power minus 8, right? Negative value. Now resistivity of insulator will be very high, so it won't allow current only, it will generally resist, right? So resistivity of insulators are more, so you will be seeing only positive values: 10 power 12, 10 power 15, 10 power 17, 10 power 12 to 10 power 17. So this is how we need to identify metal alloy and insulator. Something which are having 10 power positive value, then they are insulator. 10 power negative value, they can be metals or alloys. How to remember whether they are metals or alloys? If they are combination of copper, manganese, nickel, for example manganese is an alloy, constant 10 is an alloy, nichrome is an alloy. Aluminium is basically what? Metal. Chromium is what? Metal. It is not combination of anything, right? It is a pure metal. Mercury, manganese, copper, silver, these are all what? Metals. Now there are some questions where you need to identify whether it is a metal, alloy or insulator. At 20 degrees centigrade, the resistivity of three materials A, B, C are as follows. A value resistivity is given, B value resistivity is given, C value resistivity is given. So C value is what? 10 power 12. So positive value, then it is what? Insulator. We know this thing. Now we are having a confusion whether in A and B, right? A can be metal or else alloy, B can be metal or else alloy. We know three alloys, right? Manganese, constant and nichrome. These values are what? 44 into 10 power minus 8, 49 into 10 power 8, 110 into 10 power minus 8. Do we have these three values? No, right? So these two are what? Metals. Okay, these two are metals, and next one is what? Insulator, because this is having what? Positive value. We know what alloys, we are having three alloys: manganese, constant 10, nichrome. 44 into 10 power minus 8, 49 into 10 power minus 8, 110 into 10 power minus 8. These three values, if you remember, these three values are not getting matched, so these two are metals. Name the resistivity of a wire made of an alloy. Generally, the resistivity of a wire made of an alloy is generally lower than the metal or higher than the metal. So if you see the table properly, as we go down, the resistivity is getting increased. So compared to metal, alloy resistivity will be higher. Compared to alloy, resistivity of insulator will be higher. So resistivity of alloy is greater than metal, so higher than the constant metal. What happens to the resistance as the conductor is made thicker? Now if the conductor is made thicker, so area, basically it has more area. We know what? Resistance is inversely proportional to area. If area is more, resistance will become less. So answer is what? Resistance will become less. Name the material which is used to making heating element in the electric iron. In electric iron, we will be using some material, right? That material is nichrome. Why nichrome is used? Why nichrome is used means nichrome has very high resistivity, so due to which it will allow more amount of heat. In electric iron, we need more amount of heat, so more amount of heat can be allowed only when the resistivity is higher. So nichrome is one material which has high resistivity, so due to which the heating element made of nichrome has high resistance and produces lot of heat on passing current. A copper wire of length 2 meter, length is given as 2 meter, and area of cross section, A value is given as 1.7 into 10 power minus 6 meter square, has a resistance 2 into 10 power minus 2 ohms. What they are asking? They are asking us to find rho value. We know the formula, R is equal to rho L by A. So to find rho, what is the formula? R A by L. What is R value? 2 into 10 power minus 2. What is A value? 1.7 into 10 power minus 6. What is L value? 2. So 2 gets cancelled. So here you left with what? 1.7 into 10 power minus 8 ohm meter. So this is the resistivity value. Everyone listen. A 6 ohm resistance wire is double up by folding. There is a wire. Let us assume the length is L. I have folded such that it became doubled. Okay, it became double. So what is new length? L by 2. Calculate the new resistance. Here resistance is what? 6 ohm. Let us assume this area is what? A. This area will become what? 2A. Now same wire, if we fold, okay, if we fold, here the resistance is 6 ohm. What will be the new resistance? As length and area is changed, so resistance might be changed. We don't know, right? To find that, what we can do is, in place of R, what we can write? Rho. What is the length of wire? L. What is the area of wire? A. So rho L by A value gives us what? 6. In this case, to find R dash, what is the formula? Rho. In place of L, we are having what? L by 2. In place of area, we are having what? 2A. So what we can write? Rho L. This 2 we can send into denominator. Then that 2 and this 2 will get multiplied. So rho L by 4A. So 1 by 4 if we take outside. So here we will left with what? Rho L by A. What is rho L by A value? 6. 2 2s, 2 3s. What is 3 by 2? So resistance has changed from 6 to 1.5. If we change, hello, if length is getting halved and area is getting doubled, what is happening to the resistance? Resistance got decreased by 4 times. So initially the resistance was 6. Now 6 by 4 is what? 1.5. Okay. A similar question. A piece of wire of resistance 20 ohm Given resistance is what? 20 ohm. There is a piece of wire drawn out so that the length is increased by 2 times. Length is increased by 2 times. Now the new length is what? 12. Now when we increase the length, what will happen to area? Area will get decreased. So in the question they had not given, but you need to assume the area has become halved. If length is increased by 2 times, area will be decreased by 2 times. If length is increased by 3 times, area will decrease by 3 times. So what is the new resistance? Now in this case, length is L, area is A, the resistance is what? 20 ohms. In this case, what is the new length? 12. What is the new area? A by 2. So what we can write? This A by 2 we can send above. It will become 4 rho L by A. What is rho L by A? 20. So what is new resistance? 80 ohms. Like this we need to solve. So in this video we have learned what? We have started with Q is equal to Ne. Next I is equal to Q by T. Next we have learned V is equal to W by Q. In place of Q we can write Ne. After this we have learned what? Ohm's law. V is equal to IR. Next we have learned what? R is equal to rho L by A. From Ohm's law we have learned one more method. V by I value is equal to what? Constant. We have learned all these things in this video. In the next video we will be learning series, parallel combination, heating effect and power. How to calculate power. And we need to calculate energy. In this next video I will be explaining you all these topics. Thank you.